let's take a look at this example. We're supposed to find the currents in this circuit. We're going to start solving this problem from looking at the diagram. Okay, the very first thing which you're supposed to do is supposed to look at the polarity of the diode and the power supply. Okay, we are going to, like always, assume that current flows from the positive terminal of the power supply to the negative. Okay, so we can say that the positive terminal of the voltage source is connected to the anode of the diode, okay, which is basically positive terminal. So positive goes to positive and negative terminal is connected to the negative terminal of the diode. So we can say that the diode is forward biased. Okay, forward biased, so we can say that this is in the on state. Okay, so we're going to write the equations first. We're going to use KVL, Kirchhoff voltage law, to write the equations. I'm going to start from this point. My favorite point is always starting from the negative terminal of the voltage source, and I'm going to first find the equation for this loop. Okay, so current flows from the voltage source to the resistor. So anytime the current is entering component, you're supposed to mark this terminal positive. Anytime current is leaving the component, just mark negative. So if we're starting from this point, and we're going to go clockwise, so what we're going to see first, we see negative voltage source, right? After that, we're going to see plus voltage across the resistor plus the voltage of the silicon diode. So I have negative voltage source plus I2 R2, okay, because I times R is the voltage, plus voltage across the diode. Everything is equal 0 volts. Okay. Next, you're supposed to realize that if we are going to find the current which goes to resistor R2, this current is going to be the same current which goes through the diode. So if you are going to find this current which goes through resistor R2, I'm going to find at the same time the current ID. So what we're supposed to do, we're supposed to solve this formula, right, for I2. So what I'm going to do first, I'm going to move my voltages to the right side. So I have I2, R2 is equal voltage source minus VD. And in order to find I2, I'm going to divide both sides of my equation by R2. R2 and R2 will cancel out. So I have ID, which is also equal I2, is equal voltage source minus VD over R2. This is equal voltage source 5 volts minus 0.7 over R2, which is equal 22 ohms. Okay, this is equal 195.45 milliamps. Okay, so this is the current which will go through this resistor and through the diode. So we found ID. Next, we're supposed to find the current which will flow through the resistor R1. Please notice that this resistor is connected across the voltage source. So it means that across this resistor, I'm going to have 5 volts. Okay? So if you want to find R1, you simply use Ohm's law and divide voltage source by R1, where voltage source is equal to 5 volts over R1. R1 is equal 12 ohms, everything is equal 416.67 milliamps. Okay, so this is the current which will go through resistor R1. This is my I R1 and it was I R2. Next, we're supposed to find the total current. Total current will flow over here. This is my I total. Okay, so if you want to find I total, you're supposed to realize that I total is going to split into two currents, I1 and I2 at this point. So in order to find the total current, I'm supposed to add these two according to the KCL, Kirchhoff current law. So I have I total is equal I R1 plus I R2, or we can say I2. Anytime I write I2 or I R2 in this case, it means exactly the same thing. So I have I R1 is equal 416.67 milliamps plus I R2, which is equal 195.45 milliamps. Everything is equal 611.12 milliamps. Okay, so this is my total current. So we can say that the problem is solved.